In the cold black silence between the stars, the universe appears calm, eternal, immutable, a tapestry of glittering lights frozen in time. But nothing in the cosmos is truly still. Every star you see is changing, slowly, silently, relentlessly. Some are just beginning their lives. Others are nearing their ends. And some are already ticking. There exists a rare breed of stars, titanic, bloated, and unstable. These are not ordinary suns. They are the red supergiants, the dying embers of once mighty stars, now on the brink of catastrophic collapse. To look at one is to peer into a cosmic countdown, a doomsday clock, and when the clock strikes midnight, the universe explodes. Red supergiants are among the largest stars in the universe, not the most massive, but the biggest by volume. Imagine a star so vast it could swallow the orbit of Mars or even Jupiter. These giants are swollen, seething, and unstable, stars that have reached the final stages of their evolution. One of the most famous is Betelgeuse, a red supergiant glowing ominously in the shoulder of the constellation Orion. It sits more than 600 light-years from Earth, and yet it's so massive and bright that we can see it clearly with the naked eye. If Betelgeuse replaced our Sun, its surface would extend far beyond the orbit of Earth, maybe even past Mars. But Betelgeuse, like all red supergiants, is doomed. It is living on borrowed time. To understand red supergiants, we need to go back to their beginnings. These giants were born millions of years ago as hot, massive, blue stars. Unlike stars like our Sun, which burns slowly and steadily for billions of years, massive stars live fast and die young. They burn through their hydrogen fuel in just a few million years. As the hydrogen runs out, the core contracts under gravity, heating up and igniting new layers of fusion. Helium into carbon, carbon into neon, neon into oxygen. A burning onion of elements forms, each shell fusing heavier and heavier elements in a desperate attempt to stay alive. The outer layers swell. The star expands to monstrous proportions. The temperature on the surface drops, giving the star a red hue, and the massive star becomes a red supergiant. But this expansion is not a sign of power. It's a sign of collapse. Because deep inside, something is wrong. Fusion can only save the star for so long. When the core finally fuses its way to iron, the game is over. Iron cannot be fused to release energy. It only consumes it. And without energy pushing outward, gravity wins. Suddenly, catastrophically, the core collapses in milliseconds, triggering one of the most violent events in the universe, a supernova. In that moment, the outer layers of the red supergiant are blasted into space at tens of thousands of kilometers per second. The core is crushed into a neutron star, or if massive enough, into a black hole. What remains of the red supergiant is no longer a star, but an expanding ghost, a nebula of glowing gas and dust, a remnant of a life that once defied gravity and lost. So when we look at Betelgeuse, what are we seeing? We are witnessing a star in its final act. A supergiant whose internal structure is layered like an atomic time bomb. A star that could go supernova any time in the next 100,000 years. That might sound like a long time to us, but in cosmic terms, it's nothing. It means that Betelgeuse could explode 100,000 years from now, or tonight. In 2019, Betelgeuse dimmed dramatically, its brightness dropping by over 60%. For a brief moment, astronomers held their breath. Was this it? Was the great star about to die? It wasn't. Not yet. The dimming was likely caused by a massive plume of dust ejected from its surface, an immense belch from an unstable, convulsing star. But it was a reminder Betelgeuse is close to the edge, and one day we'll witness its end. When a red supergiant goes supernova, the result is both beautiful and terrifying. A burst of light brighter than an entire galaxy. For weeks, it can outshine every star in the sky. If Betelgeuse explodes in our lifetime, it will be visible even during the day, casting shadows at night, blazing like a second sun. But don't worry, we're safe. Betelgeuse is far enough from Earth that its radiation won't harm us. We'll be witnesses, not victims. Astronomers are watching, waiting, scanning the sky for early warnings. A burst of neutrinos, a flicker of X-rays, a gravitational tremor. The moment Betelgeuse collapses, a wave of signals will ripple through the cosmos. And we'll know the clock has struck midnight. But death in the universe is not an ending. It's a beginning. The explosion of a red supergiant seeds the cosmos with elements forged in fire, carbon, oxygen, silicon, iron, gold. These atoms are hurled into space, enriching the interstellar medium, becoming the raw materials for new stars and new planets. Everything around you, your bones, your blood, the device you're holding, the air you breathe, was forged in the heart of a star like this and scattered by an explosion long before Earth existed. We are the ash of dead stars, the legacy of red supergiants. Their death gives life. Their collapse creates worlds. Red supergiants are not just cosmic curiosities. They are engines of change. Without them, the universe would be a cold sea of hydrogen and helium. It is the life and death of massive stars that build the periodic table, that allow planets, chemistry, and biology to emerge. In that way, these doomed giants are creators as much as they are destroyers. They live short, dramatic lives, and their deaths shape the cosmos on every scale. Betelgeuse is the most famous red supergiant, but it is not alone. Stars like Antares in the heart of Scorpius, VY Canis Majoris, and Mu Cephei are all massive, swollen stars nearing the ends of their lives. Some are over 1,000 times the diameter of our Sun. Some are shedding mass in colossal waves, wrapped in halos of dust. We are studying them, watching them, learning to decode the signs of stellar instability. Because every red supergiant is a ticking clock, and every clock counts down to the same spectacular end. There is something poetic in the way these stars live and die. They are bright, powerful, enormous, but unstable. And they remind us that even the most massive things in the universe are temporary. That time moves forward for all things, no matter how grand. But in their ending, there is hope. Red supergiants may die in fire, but their legacy is written in stardust. Their elements form planets. Their explosions light up galaxies. Their deaths tell stories that echo for millions of years. And as we look up, as we watch the skies for the next great supernova, we are watching not just for science, but for connection, for the ancient, intimate knowledge that we are made of this, that we come from the stars, and one day we will return to them. Red supergiants are cosmic giants, fragile titans, doomed by their own brilliance. They do not last forever, but their deaths shape forever. And somewhere, right now, in the darkness of the galaxy, a red supergiant trembles. Its core contracts. Its surface shudders. The final moments tick away. And when it ends, the sky will remember. The Doomsday clock will strike. And a new light will rise from the ashes of a dying star.